Okay. What's the goal of this? The goal of this video is to use Grok to take this code, which is... This isn't accurate. Let's fix this up. No. 8. Calendar. Try to do this all on one monitor, actually. So, if I did this on the 23rd, on the 16th, no, 23rd. Because I just Section 1, fall 25. This is accurate, but this is mine. Well, that part add a description. Implements. This design implements a line. The individual is the design. The action it does, it implements, and the subject is a line following algorithm. But it didn't really implement it. I implemented. Well, what does implemented mean? I know what implements mean. That is not the meaning. This device used. Implement. Carry out, put in effect, usually by means of a definite plan of procedure. This program controls. I don't really like that word. Controls. Or is it A? Bang Bang algorithm. Who made this? Bang Bang control. Who made this? Control theory. The Bang Bang. A, yeah, I'd say A Bang Bang. Following. Logic for RSLK robot to follow black lines using its light sensors with I want to use using twice. Inputs. I think he added this, but intending it for it to be on a function. This isn't a function. This is the old one. Okay. Very cool. What did I just do? Yeah, no, keep that deleted. Just press it on the that comment. And I'll use LED state. Delete that. Yes. Made it cleaner. Do adjustment for terms. Minimum adjustment. Note. I like to increase the speed of the if a better algo is used. Okay, so what this is this is a like using this RSLK like robot, and it's like I flash it to this MSP432 board attached to this RSLK robot. Can I open that in a new page? Damn, bro, 13,000. That's ridiculous. Maybe because it's like out of production now? That's wild. There's no reason why this should be that much money. That is ridiculous. So, there's light sensors on the bottom of this. In paste. What? Come on. There we go. Sensors strung along the bottom of this in what would contrast really well with red. That's a good question. Quick. White. Okay, white's not gonna work though. Black, no. Green. Green would contrast well, I think. Decently. Yellow. They all kind of don't. Well, green. 1, 2, 3, 4, 5, 6, 7, 8, right? Sensor 8. Yes, there's 8. And they're like in a line along the bottom of this thing, and they scan. I don't know how the sensor exactly works, but it can detect if there's a black line. If it's set on like a white piece of paper that has like just a singular black line on it, it's white everywhere else. So, for example, this. Wait a minute. Never use. Just paint that off. Close that up, and then bucket. Singular black line. Just damn, it's missing pixels. Poor design. I guess it doesn't want to change the shape of the line you drew, and it might do that if you add the pixels in. No, it wouldn't. You can fill that in without changing the shape of the line. Mistake. It can if you were to reimagine this sensor array as like this, if the robot's driving over it, and you have all those sensors, then if the sensors that are on the black part are, on the black part, then it registers them as, I don't know, active high or active low. One of those two. And then the other ones are the opposite. I'll have to check the code to see what it was specifically. But, yeah. And then what we do is this is just setting them all as initializing it to 0. And you get the value for each one, we store it in the array, and then what we do is we split it down the middle, and then take these and add them up and call it sensor left. So add the values of this. So, so what's actually going on here is, yeah, we just add how many of the sensors are toggled active. So I guess it's active high then. because it's adding ones. And then line seen if it's 1. So when black is seen, it's active high, it's 1. So let's say like this might be wrong. I don't know which side is sensor 8. Or let's do left to right. Let's say this is sensor 0, 1, 2, 3, 4. So 3 and 4 see it. So sensor 3 plus sensor 4, that's 2 ones. So it's 2. So sensor left is 2. And then sensor right, assuming that it's symmetrical, would also be 2. If you add these two together, it's also going to be 2. And then these two are going to be low right here. But now that we have variables measuring how many sensors are active on the left and the right, you can kind of like track how, like, where the line is now. You're starting to track the line. So obviously if the number is greater than 0, that means a line has been seen across both sensors. And then this is starting to get into logic that I didn't write myself. I had the LLM work it out. But there should be a tracking mode, which it calls bang bang algorithm. And now I'm just kind of realizing that. So we actually had this robot do a few test runs for Lab 8, and our TA had to like certify it to certify that it worked, and it had to do like a track that was like, assuming the line was thicker, it's a track like this. You set it up, and then it has to go like, and imagine blue is that path of the actual robot itself. Starts on the dot, and then it travels, and then it kind of corrects for itself, and then it reaches the end. And we had to make sure that it was able to reach the end. It was able to follow the line as expected with 2 right-hand turns. Not exactly right hand. It was like a little bit rounded, because the line had thickness, so it was like rounded corners. But what our robot did is it would start, get a bunch of error, and then like once it stopped finding the line, oh, there's also a search algorithm in here, so it would be in tracking mode, it would go until this point, and now it's deviated far enough to the line where it can't see the line anymore. So it's like, oh, we gotta find the line. And it knew that it was traveling away from the line in the left-hand direction. So it knew that it needed to go right, not left. It knew it deviated from the line and needed to make a correction by going a little bit more right until it found it. So what it did was it did like a spin. Now I'm thinking about it. Now this search algorithm actually seems kind of shit. But it would do a spin, and it would then begin correcting itself. It would turn clockwise until it saw the line again. And when it saw the line again, it would be like at this angle. So what would happen is it would be like really inefficient. The sensor array, which I'm going to keep using green, would hit it like right on the edge. And then right when it detected a little bit on the edge, it would hold that angle as fixed and then begin traveling on that angle. So what would happen is it would do the same thing. So if you were to like imagine that this singular portion of the line and then keep it going further without doing the bends, the robot in our existing algorithm was like a ping pong ball going across the line like this, which is extremely inefficient in terms of like, it's like one of the longest paths it could take to actually reach the end of this line. You know, obviously the most efficient is traveling directly parallel along the line itself, right on top of the line. This is the best case scenario, and ours didn't do that. Ours was like following the edge. And actually, if I remember correctly, this is actually what the path looked like, but it would start blue, it would do this, it would do this, and then this one would actually look good, where it would do this, and then it's trying to follow the curvature of it, and then I think like we got one attempt where it actually did that, and then smoothly like went back as well. No, I'm actually remembering it now again. And this actually isn't what... This only happened... no, this isn't what happened when we actually changed it, so the speed was lowered. So right here, actually, going back to this is why I'm adding the comment here, or why I added the comment up here. I would like to increase the speed of the wheel later. So we had a higher speed, and the robot traveled really quickly. But what we did... What was happening is that the robot would... Oh, wait, what am I changing? No, I'm not changing anything. Okay, there we go. So what would happen was the robot would just go straight. It would go like... This image is actually... What I just said here was kind of incorrect. It would go like straight line out to the outside, and it would like stop on a ball, and the brakes are like... Shit. We didn't actually brake properly. Which now I'm thinking about, that could actually be a contributor for why the robot was, that could definitely be a contributor for why the robot was having problems. So what would happen is it'd go really fast here, then stop, and the stop mechanism would literally just be one of the wheels just locking up. So the wheel would lock up, and then it would like jerk. It would like jerk, like one wheel would literally go off the ground, it would pop up off the ground, get a little air time, and then stabilize, and then it entered search mode, and search mode would rotate it in, like I said, like the clockwise direction, because it knew that this was the distance, not like on the other side. It knew that it was like, it needed to travel like right to hit it. So travel clockwise in a circle, but I think because the air time carried it too far away from the line, so what it would do is just start spinning, and the logic we had designed for it, or the required design as stated by the lab, was that it would have a lost mode where it would spend 10 seconds trying to do a search before it canceled. So what would happen is it would spin around for 10 seconds and then stop. But once we changed it so that the speed was slower, this is what would happen now. The tracking would actually implement the curvature better. So what would happen was it would go here, and then it would start following the edge of the line. So it would start riding it on the edge of the line, which is very prone to error, as you can expect. So it would be riding on the edge of the line, so that green, like that far right sensor was just keeping it so where that green right sensor kept procking on the edge. And then what would happen is when it got to here, then suddenly it would let me try to think about this actually, because if it was traveling directly perpendicular to it, this could actually pose like a pretty big problem, because if the sensor if the sensor is like here and it's not detecting it anymore, then it would go into search mode. So it would rotate the wheel now, and either 50-50 whether it goes either direction or not. So there's actually the possibility here that it turns right, and then it reads the sensor as this, and then it starts traveling backwards, which is not good now that I think about it. So that's definitely an error. And the only way to correct for that is to change the algorithm, or the only one that I can think of is to change the algorithm. But anyways, it went like on the successful trial attempt, which was like 1 out of 10, is it went like this, and it just happened to turn the right direction. It went here, did search mode, went here, did like a little curvy thing, and then started riding, tried to ride the edge until here, and started riding the edge here, and then it rode the edge in a circular path. It rode the edge in a circular path, but then exited right here, because now it's riding the edge on this side. And then it would actually continue doing loops. Anyways, our TA said this is not gonna suit because, like I just saw right here, there are edge cases in which being on the edge and having only a single sensor worth of, like, I don't know, reliability. Your failsafe is riding on one sensor, where instead, if you were having an algorithm that trended towards the middle of the line itself all the time, it always wanted to get in the middle of the line, then you're going to be, it's not going to experience those errors as, or it's gonna reduce the edge cases. Yeah, and it would also be like, you could increase the speed, obviously, because the bang bang without the, it would require a lower speed. It required a lower speed to even be like accurate whatsoever, and it was literally like one of the most inefficient. So one of the most inefficient ways of traveling this path. So what I'm gonna do now is use Grok to implement the PID controller instead. So the bang bang, which I think should be pretty easy. So that was like a lot of exposition for, I think, a pretty easy change, and one which I won't really be able to test, but this is for fun. Okay, PID. Oh wait, I still have it copy and pasted. I don't need to do that. Captures the C block. PID control, there's a... I really do not like this standard of having II. Why not just have I? Float, weighted sum, that... Oh no, does this use a float as well? It does use a float. And it uses an int. Eesh. I don't know if we're allowed to use that in our lab. That's not super important right now. Oh yeah, and I'll have to tune the parameters, but I can't do that because I don't have the bot right now, so I'll just add these in. Loop time. In main loop, place bang bang. Okay, that's how I thought. And PID control after float error set point minus pause. Float error set point minus pause. Add last error equals error for search compatibility. Yeah. For example, that is what I was talking about when there's the line and this dude is going this way. Last error is the variable that handles which direction it was going in, I'm pretty sure. In last error equals error, and last error is a signed 32-bit integer. So it'll be positive or negative to count for the direction. I don't know what the sign convention is, but it's either positive on right, negative on left, or negative on right, positive on left. In bang bang, if online is less than threshold, return.
See the curtains hanging in the window in the evening on a Friday night. Little light is shining through the window, lets me know everything's alright. Summer breeze makes me feel fine, blowing through the jasmine in my mind. Summer breeze makes me feel fine, blowing through the jasmine in my mind.
Okay, float.
See the paper laying
Should I
on the
add that?
sidewalk, a little music from the house next door.
I need to
So I walked on up to the doorstep, to the screen
add to substitute it.
Summer breeze makes me feel fine, blowing through the jasmine.
Okay.
Summer breeze makes me feel fine.
Curiosity, how does this actually integrate? Oh yeah, it's discrete, so it's not an actual integral, it's literally just the accumulation.
And I come home from a hard day's work.
F of x minus x minus 1 over slope. Wait, no, dt, what's dt? dt's loop time. Or no, it's change in x, delta x, change in, yeah, x plus 1 minus f of x over change delta x. Kp times error, ki times integral, k report. I'd really like to do this like proportional. To rename this proportional, just for my own understanding. I don't know if that's right or not. Centroid. Analogous to average. Total's 7, right? No, total's however many were ones. Why is there a weighted sum now? What's actually going on here? There's a weighted sum, total. And it converts it to floating point on this line. I wonder why. I've never done this in C before, but there must be a reason for why it does this instead of just val equals sensor II. Yeah, and they have to add these F's everywhere, so to signify floating point, I'm assuming, so probably just specific to C syntax. Weighted sum, or best practice, weighted sum plus val, the value 1 or 0, times II, times its current, the sensor number, I don't get that. Why is it times II? Like, why would it weight the last sensor more heavily than the first sensor? The first sensor is literally going to be times 0. It's not going to contribute nothing. Right? 4, 0. Sensor 0 is 1 or 0, which is val. 1 or 0 is in here. And II is 0, so it's 1 times 0 is 0. Total plus 0 is total. Total is equal to 0. The first loop. This is a grok question. Function. How does both function? Wait a minute. Sensor 7, iRig, and sensor. centroid. So if maybe a better one, whatever, that's good enough. So if the centroid is here, then it knows the line is averaged to here. It doesn't know the width of the line, it just knows, I mean, it knows at the accuracy is at, it's got to be at least this. That's what it thinks it is. It could technically be longer, actually. So if it's here, then the line could hypothetically be this big. All it knows is what's within here. So it's actually likely, whenever it's centroid right in the middle, it's actually likely that the it's longer on either side than you're expecting. And if you're doing, like, say right here, then it means that there's a definite cutoff on this side, but this side is probably much larger. And then if you just symmetrically flip that, when it's on this side, you know there's a fixed point where it cuts off here, but you don't know how much farther it goes on this side. So we really fuck up for like a really massive line, because then it doesn't know where to go. It really needs those boundaries. So optimally, the line should be smaller than the sensor array, which I think it is, so we're good. Value is 1.0. Sensor detects the line. Later position. A sensor array, assuming it's leftmost and rightmost. Okay. So set point establishes the middle of it, and since it's from 0 to 7, the middle is 3.5. Okay, so I see how 0 contributes. 0 is the left-hand side, 7 is the right-hand side. So that was just like a mathematical, conceptual misunderstanding, but 0 actually does contribute. It weights it to the left. Even though 0 is 0, it's nothing. I was thinking, like, I had an intuition that 0, it's nothing. But no, it actually does drag it. It drags the total value to the left. Okay. And that's pretty cool. So that's how it maintains its goal of running parallel to the line. It wants to it always is making an attempt to keep the computed centroid at 3.5. So if the line's here, and I gotta do too many back, but if the line is, instead of here and here, it's instead here and here, this is golden because it's 3.5. Likewise, if it's here and here, golden 3.5. Likewise, if it's here and here, it's golden because it's 3.5. But if it was, say, here and here, it's not 3.5. It's this. Therefore, the robot needs to turn slightly. Very slightly. Try to re-establish that line. I get it. Why is this loop delayed? Pretty cool shape. Pattern. Yeah, this would be too much for the lab. This is a better way of doing it. How I would do it if they actually let you be creative and utilize. Leave the only constraint the actual hardware itself. Hardware and energy requirements. Power requirements. Yeah. Well, regardless, what is this? This is old code before I had the new revised. Oh, no. I'm almost like daydreaming, but isn't the purpose of search kind of like not good? So if I wanted to increase the speed of this device as much as possible, so because I want it to be like, crazy, like do like a crazy racetrack. I want it to have like an insane racetrack, and then it like all the way through, like that, crazy, very quickly. But to do that, I would need the loop to be running way faster, probably. Because if the loop isn't running faster, there's the possibility that on the very first right-hand turn, if it scans it once here, and then it takes this long to do it again, it's gonna be an issue. It's gonna be like, what the hell? I'm not on the track anymore. And then it's gonna do search mode, but the error would be cooked. So it needs to be at least like, it needs to be faster. And a big problem is when I go into search mode, it immediately stops one of my wheels, which is bad because if I'm going fast and it stops the wheel, you get airtime. So I need to modify the search so it does a sort of braking process. So I don't have brakes, but I could just slow the PWM on the wheels so it drags itself to a stop. Or it, you know, just has like a slow down. Like if you have speed, it goes down instead of just sharp drop, it steadily decreases. I don't know if there's like a best way of doing that though, physics-wise. If having like an exponential is good. It's probably just best to do it like this. Probably go like this, and I can drop it, maybe. I don't know. But slowing the wheels down would probably be good. think I want to call bullshit on this because... Yeah. I don't know why it keeps getting stuck on this. I think it said the same thing when I was doing the lab a few days ago. But generate PDM, I'm 90% sure does start the timer. So you don't need to do it again. And the fact of it is the code already worked before, and I haven't changed it in any substantial manner that affects if the timer would start or not. So therefore, whatever was going on already, whatever was already included, was working. So this is wrong. Regarding the assignment bugs, I thought I fixed those. If button state, button on, button off. This is right, this is right, this is right, this is right, this is right. Button state B 0 button state is equal to button off, and stop if yeah, generally this is actually, I think this is a pretty bad prompt in my experience to give LLMs with regards to code, because it's like, I don't know what the name of the bias is, but it's like that bias where it's the question is biased towards it, not the response. Is the bias in the response is to say it's not functioning. It's way easier to find branches where it's not functioning. It just requires one thing to say it's not functioning. But to say it's functioning, it requires you to prove that everything works. Every single thing. Either you prove one thing is false, or you prove the entire system works. And when you're trying to prove the entire system on an LLM, obviously it's like there's a lot of problems, because the LLM will you know, there's a probability that every single thing it'll get, if it's checking every single thing like an individual instruction, the chance that one of those is gonna hallucinate you're gonna have an error hallucinated in one of those is, you know, high. I think this is just wrong. PID, this might be right because this is new. Search direction's wrong. This actually could be right. Motor L turn left. No, that's right. Oh, wait a minute. Oh wait, but this is the corrected, so maybe it is wrong. Motor L state. Less than 0. L turn, last line was on the right. Turn, okay, so that wasn't really the error then. Turn right, but that's not the way I was thinking about it. Turn right, left fast, right slow, reverse. Forward. And R turns right. So this sounds right for turning right, but I think the problem is more so with the fact that the last error being negative means that you should turn right. This one's saying if the last error is negative, then you should turn left. So I'll just add a comment here. Test to in test to ensure that directions are correct in performing lab 8. I'll make a mental note of that. I'll remember that when I'm actually doing it. e.g. last error less than 0 may signify a left turn is needed, not right. That's probably more nice. I don't understand the context as much. Uh-oh. These two could be just both wrong, and then they were trying to justify it. Anyways, this is like not low-hanging fruit anymore. Yeah. Not low-hanging fruit anymore, so I'm just gonna close it and then that. Good progress on our